2024 was a crazy year for the bundler wars. From RsPack to Farm to Bun, things just kind of got wild. But instead of slowing down as we approach 2025, it looks like we're going to be going even faster, like as fast as Rust. Because Rolldown 1.0 is finally in beta, and this is very exciting, especially for y'all Vite users, because Rolldown is going to fundamentally change how Vite works, and with that, we should get some really big performance wins. You know what else I hope performs well? This sponsor. Today's sponsor is SingleStore, and if you're dealing with an old Mongo database or are tired of trying to figure out vector stuff, this one's for you. When they say they're the only database you'll ever need, they actually mean it. On a single query, you can do everything from crazy vector lookups to keyword matches to sums and dot products, all the crazy stuff you have to do for analytics in the same query, and it's super, super fast. It's so fast that if you use them as a drop-in replacement for Mongo, yes, you can just drop it in an existing Mongo project. It is 100 times faster. No changes needed in your code. You just switch the connection string to SingleStore and it works. Their free tier is free for life and you can self-host it in Docker. It's fully compatible with the MySQL Wire protocol, so anything that works with MySQL will work with SingleStore. Same with anything using Mongo, which is kind of nuts. Crazy to have all of that support, all of that functionality in a single high-quality database like what they built here. Thank you, SingleStore, for sponsoring. Check them out today at soydev.link/SingleStore. So Rolldown is possibly the new bundler I've been the most excited about, both because it has the most obvious path for adoption, but also it's taking one of the biggest bets. There's a couple bundler projects going on right now, and we should probably talk about them all in order to understand what makes Rolldown so interesting. For a long time, there was one bundler, Webpack. You've been around for almost any amount of time. You're probably relatively familiar. My original web dev journey kind of started with Webpack. It was my first real deep dive into modern web. It was trying to upgrade some projects to the latest version of Webpack. I think it was the 1 to 3 upgrade, which was, I learned a lot. Let's just say that much. There are things before then, the good old Browserify days. Browserify, right? Yeah. Browserify is like the OG, but Webpack was the one that like really took over. There have been other notable efforts, though. The big ones, I would say, are Parcel and Rollup. Parcel is largely by Devin Govette. He works at Adobe, and the goal was almost like it fit alongside like Yarn, if that makes sense, where it looked at things Webpack was doing, and it was like, I see you, bro, but there are some opportunities here to make things suck a lot less, and that's the direction Parcel is trying to do, is almost like a Webpack, but finer tuned type thing. Rollup, however, was created by someone y'all might be familiar with if you're here a lot, Rich Harris, the creator of Svelte. And Rollup was a fundamental rethinking of what a bundler should be, with the goal of being way simpler and way less config. I still remember the first time I dove into Rollup and was trying to configure all of my bundled chunks and outputs. And then I realized Rollup, if I gave it no config, actually did a better job bundling because its semantics around all that it's a great bundler. Rollup is awesome. Personally, of these, Rollup is the thing I liked the most, but Webpack is the thing that was the best supported. So it's what most of us ended up on, especially us React devs, especially us Next.js devs. But this was, you know what, I'm going to break this up. We'll have Gen 0, which was Browserify, and Gen 1, Webpack, and eventually Parcel and Rollup. I'm counting these all as the same generation. People might be mad at me, whatever, because we're here today to talk about Gen 2. Gen 2 was kicked off by a really cool project named ESBuild. ESBuild was created by Evan Wallace, who was the CTO of Figma at the time. His goal is to make a really fast builder and bundler for our JavaScript code. Imagine a code base the size of Figma's and how slow things must be in that world. ESBuild was from scratch written in Go, which at the time, almost all of these bundlers were written in JavaScript. So it was a big deal to write it in something else. And we can see the performance win here. Webpack was at 41 seconds for this test build. Rollup 4 was at 35 seconds. Parcel 2 was closer to 15, still way too slow. And then ESBuild comes in at 0.39. The important thing to know about ESBuild is that it's not a bundler in the traditional sense where it bundles everything into one JS file or the right subset of JS files that you're looking for. ESBuild is more a transformer. It takes all the fancy syntax and things we write in our JavaScript, like, TypeScript or, React code with JSX, and it transforms all of that into JS that the browser can run. But when you look at what ESBuild outputs, it's not a small number of big files. It's a giant number of small files. And if you have a big enough code base and you're using ESBuild, it might just not work for you because the browser can't load that many files. So ESBuild, despite being revolutionary, which it absolutely was, it wasn't quite production ready in the traditional sense. But for things like dev builds, incredible. I'm going to move this lower, and you'll understand why in a second. Another project that you might have heard about, on and off, depending on how often you're here, TurboPack. TurboPack is actually created by the original creator of Webpack, who now works at Vercel working on TurboPack full-time. The goal of TurboPack is to make a from-scratch Rust-based rewrite of Webpack that is as close to fully compatible with the Webpack API as possible. The goal being allowing us to take all of our old Webpack code bases, move them over to TurboPack with 0 or near 0 changes, and just have faster builds. It has taken a while. I have no idea if it will ever happen. Maybe someday, but we're going to have to hope. And hopefully all of this helps a little more with the context for Rolldown. If TurboPack is the Rust rewrite of Webpack, Rolldown is the Rust rewrite of Rollup. You might be thinking some weird thoughts right now, like, why are we rewriting both of these? Why aren't we making something new? Why does anyone care about Rollup? Especially the creator of Vite. Because Evan Yu created Vite. If you're not familiar, somehow, watch more of this content. And yes, our RIP Snowpack, it deserves a shout out here. I don't know where I'll even fit that though. Vite is very interesting because Vite's not a bundler in the sense that it actually is the thing that turns your JavaScript into other JavaScript. Vite is a bundler that doesn't do the bundling itself. Vite's actually two pieces. Vite is using a different bundler in dev and in prod. Because in dev, it's okay to have the huge pile of those JS files, but in production, you want an actual minified set of files. So with dev, we have ESBuild, but in production, Vite uses Rollup. This is great because you get insane, like literally instantaneous hot reloads when you're using Vite in dev. So when you make changes, you see the change super, super fast. But in production, Rollup is used instead, so we still get all the fancy bundling characteristics and optimizations that Rollup has baked in. There's a couple problems though. First and foremost, you now have different bundlers for these different environments, which can make trying to match behaviors across them annoying. A lot of work has been put in for Vite plugin authors and people building frameworks around Vite to make sure that both dev mode and prod mode work properly because these things are so different. It also means that you don't get the incredible performance that you expect from Vite once you actually start shipping the code to a server to be built. The building and the bundling of an app with Vite for production does not see the massive performance wins that you see in dev mode. It also means once your code base is big enough that the dev mode starts to have problems because you have too many files going to the browser because it's not taking them all and putting them into one JS file. It's creating a new JS file for every single thing in your code base for the most part. Evan Yu saw this as a challenge. This stack worked great to get Vite where it is today. This is still how you're using Vite right now, almost certainly, depending on how long this video gets viewership for, to be determined. But today, things change because if Rolldown is successful, we're going to have one bundler for both of these. We're going to be using Rolldown for both. This is dope for a bunch of reasons. First off, we now have the same thing in dev and prod. Second off, the entire Vite ecosystem should continue to work as expected because if Rolldown is properly API compatible with Rollup, then all the plugins can just use their production mode and it works in dev too. This is a very promising development. And all the numbers that I've seen so far are very promising overall. If we look at their benchmarks, which I actually took the time to run, we'll see if we compare Rolldown with RsPack, ESBuild, and Rollup, all in a code base that has, I think, 10,000 files is what I ran this on. You have a 10,000 file app. Rollup took 22-ish seconds to run. ESBuild took 800 milliseconds, so a bit under a second. RsPack took 2 seconds, which is still really good. Rolldown took 600 milliseconds. This is what's so cool about Rolldown, is we're getting numbers slightly better than ESBuild, but with all of the bundling characteristics and behaviors that we would expect from a true, fully fledged out bundler like Rollup. But what does this mean in reality? Well, sadly, from my experience so far, reality is not quite as shiny as these numbers look. There are places that I'm seeing a performance win already, but I want us to be as realistic as possible about where this is today because this is the 1.0 beta and I'm excitedly trying to adopt it. So I have this quick code base I threw together that is meant to test this. It's a really simple create Vite app. This is using the standard version of Vite. I have a branch that is using the Rolldown version. I'll show you in a sec. But I also got some help from Claude to generate 5,000 components myself. So this creates these 5,000 basic examples of a React component with state management, just to use state on them all. It creates one for each of those 5,000 and then generates a file for all of them. So I have this folder that has 5,000 components in it. To keep them from tree shaking out, I have this one file that imports all of them and then mounts them all. This file is not small, 30,000 lines to mount all of these in it, but it works and it lets us have them all in one spot. I thought this would be a really good test, so I ran it. Check out Rolldown. Right now, Rolldown isn't officially in Vite, so there's actually a fork of Vite that has Rolldown support that I'm using a package PR new build of. Admittedly, this slows things down a bit because it can't be NPM cache the traditional way, but not enough to justify the lack of performance win I experienced. So the thing I care about here is how does this affect the time for when I trigger the build to when it's actually in production? Because that's what I'm really excited about. This is the first really production-ready path for a lot of apps to stop using JavaScript to build their JavaScript. We use awesome tools right now like TurboPack, we're in Rust, and ES Build and Go for dev, but none of these tools are recommended for production yet. So I was really hoping to see some big wins here. This is the first build I ran. This one was using standard Vite, everything configured the basic boring way. The build time, about 11.5 seconds. And it created this big file, this 2.8 megabyte file. And this is all the JS in that single file. If we compare this to the Rolldown version, it built in 7.47 seconds, which is better. It's just not as much better as I was hoping. There is a concern though. The bundle came out significantly larger. There's a lot of potential reasons this would happen. I don't feel like theorizing about them because I will make a fool of myself, but it does not seem unlikely that this here is something that needs to be fixed. I'm not sure if fixing the output size is going to also fix the speed at which it is doing the building, but I was a bit disappointed. This was a 10-second total win, which after I did more builds here, this one was Rolldown and it was 46 seconds. This one was main, which was standard Vite, and that was 48 seconds. There isn't a huge difference here, at least for this example with a giant React code base. Yeah, again, 7.5 seconds for this one versus 10.19 seconds. To be very clear, there's a couple impressive things here. First off, that a JavaScript-based bundler can bundle 5,000 files in 10 seconds. Rollup is goated. That's impressive. The other thing, though, is that performance isn't the only win here. At the very least, performance on your build server isn't. The standardization between the dev mode and the production mode is massive. You might see that one of these builds is really fast, this 9-second build. The reason why is I went from 5,000 components to 50. This isn't using Rolldown. This is just using Vite, which in turn would be using Rollup, the original version in JavaScript. The reason I want to do this test is to see if I'm actually impacting build times by including all of this stuff, and clearly the answer is yes. And it's not just that 7 to 10 second difference anymore. This says built in 881 milliseconds, but there's a lot of other pieces in the build process that aren't included in this number. And the goal here of doing these different tests in these different ways was to try and show all of those different numbers. So if your code base has 50 components instead of 5,000, the difference doesn't matter. You're already in this crazy fast build range. But as your build times crawl up because you have so many files, so many packages, and all of these different things, that's when you start to see the wins from something like Rolldown or like RsPack or TurboPack or any of these other options. And as I was experimenting, if we hop back here, I actually have this code base open. Make sure we're on the latest. npm run dev. Cool. Now we are running this giant 5,000 file dev server. And if all goes well, I should be able to hop in here, edit component 23, change this, sup nerds. I am saving now. And it appeared almost immediately, like within under half a second. I'm saving again right now. If it's falling back on old thing, it seems to be instant. Please subscribe. Saving now. Effectively instant. And this is using the exact same bundling technique that's going to be used for production. So getting that type of performance in dev with the same tooling that you're going to use in prod is huge. What's the callout you have for me here? Apparently, I don't have a minifier. Yeah. So the reason that my JS is so much bigger, it might just be because there is no rollup minifier yet. They actually recommend you bring in your own. It's recommended to use an external minifier. Rolldown's compatible with all rollup minifier plugins like rollup, plugin ESBuild, SWC, etc. Good to know. As I was hinting at before, though, the performance for builds on the server is not the only really fun, exciting thing going on here. One of the things I am most hyped about is performance in WASM. Why would anyone care about their bundler running in WASM? Like, you're not shipping the code to users to have them bundle it. Well, you're not, but companies like StackBlitz are, companies like GitHub are, companies that are trying to make good environments in the browser are. And being able to use Rolldown in WASM mode to have a fully featured editor experience in the browser, taking advantage of those performance wins is really cool. And after they made some changes to make this work better with Rolldown, the performance they're seeing is insane. ESBuilds in Go, which historically doesn't compile great to WASM because it doesn't really handle memory that well. It expects to have garbage collection, which you don't have in WASM, so you have to bring all that in. It's chaos. Rust can compile to WASM a bit better, which is why Rolldown sees insane performance wins compared to even ESBuild once you're running it in WASM mode. Super, super cool to see. And the things they're coming up with to make this happen, specifically creating thread pooling for workers in the NappyRS APIs, is huge. This is so cool. I'm really excited. Even in a theoretical world where Rolldown fails entirely, it has built so many cool foundational things and taught us so many cool foundational wins that we can make meaningful changes to our entire dev ecosystem as a whole, which is probably why they formed Void Zero, the new company by Evan Yu, focused on making the next generation of dev tools for JS and TypeScript devs. Rolldown's only part of it. The OXC ecosystem and Vite and everything around this as a whole is the future. So they call out here, Vite, Vitest, Rolldown, and OXC are the core things that, if built correctly and properly, can all combine together and make a set of tools that is significantly better for us to use as devs. Just to quickly reinforce the thing I was saying earlier about ESBuild's transpilation not being ready for real production workflows, this is a nice little piece in the Rolldown docs about it. We can't skip the build step. Build people, I don't know what code bases you're working in. I wish it was realistic. It sounds great, but it just isn't. With the general availability of native ES modules and HTTP2 in modern browsers, some developers are advocating for an unbundled approach for shipping web apps, even in production. While this approach works for smaller apps, in our opinion, bundling is still very much necessary for shipping anything non-trivial and you care about performance. Even in a polished, unbundled dev model, a build step is still often unavoidable. Take Rails 8's default import map-based approach, for example. All JS assets still go through a build step in order to fingerprint the assets and generate the import map and module preload directives. It's just handled via this import map Rails package in PropShaft instead of a JS bundler. Moreover, the unbundled approach will hit its limits if you have any of the following requirements. You need modern JS like ES6+, TypeScript, or JSX. You need to leverage bundler-specific optimizations like tree shaking, code splitting, or minification. You use any libraries or frameworks that depend on a build step, or you utilize NPM dependencies that ship unbundled source code. If any of these things are true, you need a bundler. Not would benefit from it, but need it. Going with unbundled means locking yourself out of a big part of the JS ecosystem and giving up on many possible performance optimizations that could benefit your end users. The main argument of avoiding JS bundlers is adding complexity and slowing down the dev feedback loop. However, modern JS tools have improved a lot on this front over the past few years. Our goal with Vite and Rolldown is to improve these aspects further and make the build step feel invisible. I really hope they can get there. They call out these three things that you can't get without bundlers, which are the reducing the amount of network requests and waterfalls, because one JS bundle loads, processes, then realizes it needs 15 more that'll have to go load and process, or it can ship the one bundle instead. Reduces total bytes sent. Hopefully that's obvious why. And it improves JS execution performance. That part might be unintuitive, but the TLDR is when you send less code to the JIT compiler, it has to do less work. As they call out here, there's a non-trivial cost involved in parsing and compiling JS. So if you send less JS, it has to do less work. And some bundlers and minifiers can even perform optimizations like folding and ahead-of-time evaluation to varying extents, which makes the bundled code even more efficient than their handwritten source. Bundlers are effectively necessary. I can't take people seriously that say otherwise. It just feels like they're not working on real software with real teams. Like, it's cool if you can get it working in examples. I'm not saying it isn't cool. I'm just saying it's not realistic. And what I'm excited about with Rolldown is it feels like it's getting more and more realistic. Rewriting rollup in Rust didn't feel realistic at the time, but they're getting there. They're getting there a lot faster than I expected, and I see a very bright future for Rolldown.